Hi, hello. How are you doing? Today I would like to present you the topic of stroke prediction. I've worked on this project. Coming to the introduction, various machine learning models have been developed to predict the likelihood of occurring of the stroke in the brain. The dataset that I have used for this study has been extracted from the Kaggle data source, and I use the following attributes to predict whether a patient is likely to have a stroke or not. To have a stroke based on the parameters such as age, gender, various medical conditions, and smoking status. For model building stage, I would like to firstly compare the patient ID with the hypertension measurements and average glucose level. You can also find out why the high blood pressure readings have been changed, and you can also get your patient's blood sugar levels. Next, I would like to compare these input variables such as hypertension and blood sugar to know the exact reasons behind the cardiovascular history. This analysis allows us to understand the likelihood of occurrence of the stroke. For example, you can use the data set to identify the most of the patients in the age groups are likely to have the health problems and may also have a stroke in the future or in the past. I would like to use the Python Colab for Python Colab and Tableau to perform analysis on the dataset. Modeling implements Modeling implements the API formula method for model interpretability, uses logistic regression and random forest for the linear models of the non-linear models, and also the devices uh, and non-linear relationship and association for strategy building. And I would like to solve this problem of information integrity and services. I would like to develop a strategy to solve this problem. After the analysis and data gathered from the Python Colab and Tableau, I would like to compare the following parameters based on the graphs that they produce. Like for the the for the count plot, there are some observations that can be drawn. For hypertension, subjects that previously diagnosed with the hypertension have highly risk of having a stroke. For heart diseases, that previously diagnosed with heart diseases are also having the chances of getting high chances of getting a stroke. For works type, the subjects that I have any work experience and in the healthcare or in the government related works are having a high chance of having a stroke in comparison to the people who don't have a job or any work experience. Coming to the smoking status, being a smoker or a former smoker increases the risk of having a stroke. Average blood sugar levels, subjects with the stroke tends to have higher uh, average glucose levels in the patients. Coming to the BMI does not give that indication of likelihood of having a stroke, but it is very negligible. But you need to be healthy too. And for the conclusion, I would say that ML architecture can help the ordinary people in determining the likelihood of having a stroke in adults, that is, the patients. So, this is the abstract of the project that I would like to discuss. Now, coming to the presentation. There are some overviews for this presentation like introduction, problem statement, insights, motivation, approach, outcomes, and further work. So coming to the introduction, this data set has been extracted from the Kaggle website, and they also have some following attributes that would predict whether a patient is likely to have a stroke or not, and the and the attributes that would determine the stroke are the age, gender, various health conditions, and smoking status. For each row of data, it contains the relative information about the patients, like the place from where they are coming, or the and what are the problems that they have in the past, and so on. So the total attributes that my project contains are 12, and the total number of records are 5,101 records, in which there are 2,995 are women and 2,115 are men. And coming to the next one, the problem statement. Basically, this problem statement is a kind of an overview that the project that aligns. Our task is to use this patient's medical records and also to determine whether the patient is likely to have a stroke or not. Basically, the stroke occurs when a brain is damaged this as a result of not able to get a proper blood supply to the brain. So this problem may occur. So in order to overcome this process, and also the whatever the insights that I have faced in this project have been in the next slide that comes under the insights. I also worked on the stroke prediction project. In this project, I have collected the data from the Kaggle, and it contains the input parameters to determine the different abilities were examined while analyzing the possibility of the stroke. It plays an important role in completing the analysis. Working on this project gave me the opportunity to practice the data science life cycle. As a result, the public health informatics have the collection of data and medical records, and the informatics want them to work on the data and for processing. And coming to the motivation, the motivation for this project has divided into two parts. That is the first stage and the second stage. In the first stage, I would like to compare the patient's ID with the hypertension measurements and the average blood glucose level. Next, I would like to compare the input parameters like the hypertension and blood sugar with the cardio history to know the exact reason behind the cardio history. And by this, we can predict the people can have a stroke or not. And next, coming to the approach. In order to solve the above mentioned problem statement, I would like to come up with a problem solving solution that says that it says that the health information system integrates with the processing of data from different types and sources. This challenge can be met by embracing the virtual integration and creating the healthcare information solutions and agile infrastructure. Various ML models have been developed to predict the likelihood of occurrence of stroke in the brain. Coming to the outcomes. The outcomes for this project are first, the analysis allows us to understand the likelihood of occurrence of the stroke. For example, you can also gather the data from the data set that we have used to identify what kind of health group has been affected the most for occurring the stroke. Like if you take an age group of around 40 to 50 years of age group? What are their prerequisites to occurrence of the stroke? Like, were they have any work tensions, or was it because of the health, or the exercises that they do or don't do? It's based on that we can predict the occurrence of the stroke. So I would like to use the Python, Colab, and Jupyter, and also the Jupyter and and Tableau to perform some analysis on the data set to find out the accuracy of the models that we build to predict this occurrence of stroke. Coming to the outcomes, like the basic outcomes that this project develops. So this is the Jupyter, this is the uh, Tableau version of the outcome. So when we compare this patient ID with the average glucose level, BMI, and stroke, and the smoke status, we will find out that the value that runs from 0K to 200K, the average blood sugar levels have been higher for the people who have never smoked at all. For the people who have formally smoked is around the average level, but the BMI is also quite higher for the people who have never smoked at all. So this is how this graph represents. And coming to the next comparison, when we compare the heart history, the cardio history, hypertension, location, and occupation that they do, to the surprise, we came to know that the private sector people are going to be the most likely to have a stroke because they are the way they work or the way they do things and so on. So, yeah. And giving the overview, the complete overview, and how the people have been done this kind of analysis, like comparison of average glucose level, BMI, gender, hypertension, cardio history, location, occupation, smoke status, and also the stroke prediction. We come to know that there are a lot of uh, female people who have never smoked at all have been a victim of having a stroke. So we also come to know that it's again from the private sector where the people have been working. So I find from my analysis I can predict that the people who are working in the private sector and who have not smoked in the past, and they are getting a stroke easily. So, yeah. Coming to the Python outcomes, as I already mentioned, I have used some of the regression models, and I also use the NumPy, Pandas, Mat.lib to find out the accuracy of these projects. And then I've also used the KNN model and also the correlation analysis to find out the accuracy of this project. And also there are some parameters that determine the stroke again in the same as I got the same outputs from the Tableau as if of Tableau, and the Python is also the same. So I find out that the same ratio of the patients who are effectively are been affected of stroke are in the same private sector, and also the people who are of not formally smoking or something like that, I found out. And the BMI is also quite higher for the people who are working in the private sector because of the tensions that they have and so on. I don't know why exactly. So this is how the graph works on, and this is the output, the final output that I get from the regression models and all. And then coming to the future work, I hope the architecture of AML would help the ordinary people to determine the likelihood of having the stroke in the patients. Uh, Thank you.